Hi there. After understanding the difference between equations and identities, now we are going to delve deeper into the types of equations that occur in economics. Primarily, we have the definitional equations, and as the name goes, these are the equations that represent the definitions. These are reflecting some definitions, and they can also become an identity because the definition remains the same. Hence, this equation will remain the same for all the values of the variables. The first economic example would be the revenue function and the profit function. Revenue can be calculated simply by multiplying price into quantity, so it will always be equal to the revenue. In the same way, the profit function can also be calculated, which is the difference between revenue and the cost, and it will always be equal to profit. So we can say that profit is identically equal to the difference of the revenue and the cost. Now, another thing that we can consider is that we can put an identity here, because this is definitely a definitional equation because it is defining the profit, but at the same time it is identity because the equality will always be there regardless the values of C and R. Either it can be positive, negative, or zero, because the difference can be in these three possibilities. And if it is equal to zero, it implies break even, that is, the revenues are equal to the cost. Another example is there, and that is of national income accounting identity. It's an identity, it's a definition of national income, which from the expenditure approach point of view: cost, consumption, investment, government expenditure, and exports minus imports. So these are the expenditures by consumers, by investors, by the government sector, and from the exports and imports point of view. So this is a definitional equation. At the same time, it becomes an identity. The other type of equations that we confront in economic analysis is the behavioral equation. Behavioral equation, as the name goes, it's about the behavior of certain variables. These variables can be related to the production, consumption, or human behavior. So we can also include technological and legal aspects in it, because these will affect the behavior of the dependent variable. For example, technological change can increase the value of the production, so it is defining the behavior of the dependent variable, that is production. And some sort of legislation that discourages production will also affect the behavior of the dependent variable. Now, behavior can be human and non-human, and that is something we understood already. From the point of view of human behavior, aggregate consumption in relation to national income is something we are going to see. The behavior regarding the consumption of the people depends upon what is the minimum level of consumption based upon the basic needs that they have, and then the induced consumption, which is based on the value of the income and the marginal propensity to consume. So you see, the consumption behavior is modeled in this equation, where there is autonomous consumption as well as induced consumption. In addition to human behavior, non-human behavior can also be there. Total cost in relation to output. Total cost is a sum of fixed cost and variable cost. So you see, the fixed and the variable costs, they determine the behavior of the total cost. More specifically, the variable cost has the variable output in it, so it determines the total cost accordingly. So total cost is equal to A minus B into Q. This is the fixed cost and this is the variable cost. And then we have two cost functions. One is this cost function and this is another cost function. So we can consider these numerical examples to understand the behavior of the cost. We already know that the fixed cost is the cost at zero output, so we have mentioned it here. So the fixed cost in this case is 75. The variable cost is 10 times of the output. Here the fixed cost is 110 and the variable cost is square of the output. So if we develop the schedule and the tables for the two given functions, we can easily do it by substituting various values of 0, 1 to 10. And then there is cost, and definitely these values can be found simply by putting the value of Q in this equation and Q in this equation. So we can make these two tables, and then we can also make the graphs on the basis of these. So you can see here that this is the first function and this is the second cost function. Their behaviors, they are visible. This is a straight line because the degree of the equation is 1. This is a kind of parabola because the degree of the equation is 2. So the two cost functions are representing the behavior of the cost with respect to the outputs. So this was to explain the behavioral equations. And now the third type is the conditional equations, which is the final type in our lecture. So as the name goes, this is the conditional equation and it will embed some sort of condition, and let us see how it works. It basically requires a certain condition that needs to be satisfied. And for example, in economics we have equilibrium condition, and if we write it in the form of an equation, it becomes conditional equation. And the two equilibrium conditions, in addition to the mathematical examples, are from economics, basically quantity demanded and quantity supplied. QD is equal to QS. So this equation is actually a conditional equation representing a certain condition. This is the other conditional equation representing the equilibrium at macroeconomic level. The desired savings are equal to desired investment, and this would be the conditional equation. So this is how we understand and exemplify the conditional equation. This is a diagram for the representation of the conditional equation. QD is equal to QS, and this is the diagram where we have the other possibility, that is the equality of the savings and the national level of investment. S is equal to I. So this is a couple of examples. Another example is there where the marginal cost is equal to marginal revenue, the profit maximization condition. And here you can see that this diagram explains that we have marginal revenue and we have marginal cost. They're intersecting each other at this point, and that will give rise to a certain level of output, which will be the profit maximizing level of output. So MC is equal to MR is the conditional equation that needs to be fulfilled for the sake of profit maximization of a certain firm. So these are the three types of equations that we have understood that are used in economics. This one was conditional equation. The other one was the behavioral equation. And finally, we had the definitional equation. So all these equations are used in our economic analysis. Thank you.